Hello everyone, this is Subham. This is my final year project that is titled as Structural Health Monitoring using Artificial Intelligence. I am doing this under the guidance of Dr. Subhajit Modal sir. And coming to the goal of my project is localization of defect. That is when we have a structure and we have the natural frequency values and mode 1 and mode 2 period values of the structure, then using machine learning we can predict the defect in which element number it is present. So coming to the steps achieved taken to achieve the goal. This is the bridge that I have taken. It is a truss bridge with 11 nodes, and each element is also numbered, and there are 19 elements. I have written all the coordinate values of this truss bridge. Here, node 1 and node 11 are fixed. Okay, so my first aim is to find the frequency values of this truss. For this, I have been using Opensees, and one of the best editors of Opensees is Cypress Editor. When downloading this Cypress Editor from its official site, we can download it directly from here. It is 10.22 MB. On clicking it, it should start download. Since I always, anyways, I have it, so going directly to it. This is the Cypress Editor in my desktop. Previously, I was using Notepad++, but Cypress Editor is better than this. It is a bit user friendly. So going to file section, create new, start from scratch. Give a location that is in desktop. Okay, okay, okay. It is always previously present in desktop, so I'll choose C. Okay, now a file in C will be created. Now this is my editing area. Here is where I write the code and click on run. Then it directs to the Opensees and I get the result in here. So my code is already done. So let me show the code directly. So this is my code. So the code is basically divided in three parts. The first part is modeling the truss structure, and the second part is assigning the values or giving the variables where the values will be stored. That is the k value, the frequency value, the pi value, and the time period values. And in third, it is the analysis portion where the analysis take place and the period values are stored. See here, if I have taken ISMB 600 steel structure. So now on looking at these values that I have introduced, that is RQT. R is actually 1% error induced in the area. So initially first we will check the, here as we can see, R is not there anywhere, it is all A's. So the structure is perfectly fine. That it will give the natural frequency values. So these are the natural frequency values, mode 1, and the second one is mode 2. This I have stored it in here. This is the mode 1 and this is the mode 2. Now to induce 1% error in them, so one by one I have induced 1% errors in them in the area basically. So first element 1 inducing 1% error, click on run, and this is the mode 1 and mode 2 values that I got. So as we can see, this is 58752110495552. The same data is here, 58752110999552. So this is the mode 1 with 1% error in element 1. This is mode 2 period with 1% error in element 1. Similarly, one by one in all elements, I have taken this error induction. Now basically the Opensees part is done. I got the data that I required. What was the data I required? It was the error induced data of each element's modal values and their specific element numbers. This is the data which I required. So now I got this with 1% error of mode 1, and then this. So now, as we can see, these datas are very close. So what I had to do was to do something with them so that I get a specific different value for them, which are not much closer. So what I did, we also have the natural frequency data. So I subtracted the 1% error data from the natural frequency. Then what I got was these values. See, as we can see here, it is bit2 minus E2 into 10 power 6. Then this was the data which I got. And these data are a bit far enough. Here also and here also we can see these data are bit better than the previous these data, which could not have done anything. Even if we multiply 10 power 6 to these data, it won't give any fruitful result because all the data are nearly same. So here it is the first step where we got some data a bit different or far enough. Now, but still, I thought that if we can multiply another 10 to these values, then we can get a better hold on the data. As here we can see, it was 7 and 3. I have multiplied another 10 to both of them so that it will be better for them to be clustered, well clustered. Now the data from the Opensees is done. Now going to the coding part, coding of the machine learning. That is to train the machine learning algorithm with this data. So to do that, I have used Google Colab. It is an online Python editor. Here I will start a new coding or new notebook. Okay, here it is the coding area. As we can see, the extension file is .ipynb. So it is Python. Now we have to click connect in here. It is connecting. Since this is online, it uses the GPU and CPU of Google itself. So even if my laptop does not have much GPU and CPU, the coding won't be slow. Okay, now it is connected. Okay, now I will also open my code that I have written. From this code, I will take one by one in the new one and I'll show it how I have done it. Okay, so the first portion is to import all the libraries. These are all the libraries that I have used. The k-means clustering library and the NumPy, pandas, sklearn. It is also a clustering or artificial neural network library. And shift enter. It is run. Okay, when I got these values, that is print sklearn version. That is the version of the library. Now since it is print, it means this portion is running perfectly. Now the second part is to take the data from my laptop. So from google.colab import files uploaded. Okay, now it is asking me to choose file. So I'll choose my file, that is data into 10, the CSV file. Make sure it is CSV. 0%, 100% done. Okay, now data is also done. Okay, now in the other segment, I will store that CSV in data variable and print that data. Okay, this is our data. This is mode 1 values, mode 2 values, and the element respective element numbers. Okay, so now using all the different data frames, okay, okay, shift enter, and then the next line is to plot that data. Actually, the data I have given, to plot it, having this in x-axis, this in y-axis. Okay, so this is my data. when it is plotted. So, okay, next, this is fitting the data actually, fitting the data and giving specific numbers to each of the dots. That is, a particular labeling is done to each of the dot. Some suppose this dot, it may be 0 or 1 or any of these are basically labeled. I have 19 datas with all being same. Basically, all are mirror image to each other. If you see 1 and 5 is same, but a single three number is different. So basically, I have 10 scatter points, and all of those 10 points are labeled in this way. Okay. Then going to the next part, it is fit predict. It also comes in the k-means fit predict. Now next part is to plot this one. Like after clustering, how does my data look? Okay, so after clustering, this is my data. All the different colors here we can see are clustered in a single module. Now comes the import part. What is this basically? So here we are asking the system or the algorithm to predict. Suppose the mode values is 51, mode 1 value is 51, mode 2 value is 51. Then which element number it is that is damaged. As you can see here, I have written 15, 15. So let's check actually which number it is. So first it showed us 1 comma 5, 1 and 5 element numbers. So we can see 1 and 5, it is 70 comma 32. So the algorithm is not yet ready. It may take some time. So we have to run it from this 10th line a few times. 12 and 17. Okay, what are we searching for? Let us see. We are waiting for this 16 and 13 and 16. 13 and 16 is what we should get. That is 51 comma 51. Okay. It takes some 20-30 attempts. Eleven and 18. Now we're waiting for 13, 16. Basically, the accuracy increases when the data is of more number. I only have 19 datas because I had 19 element structure. Okay. Let us change this data a bit. 50.94, 50.98. See what it is showing. 96 and 9. Okay, 13 and 16. We've got the values. Now let us change this data again. Let's take 5.95, 134.47. Okay, 5.95, 134.47. This is 14 and 15. See, we got the element numbers with the same modal values 14 and 15. Now let's check with another data 70.48, 32.64. 2 and 4. Okay, 2 and 4. No, we should have got the values 1 and 5. Okay, let's do it again. Let's change this a bit. 2. Once the algorithm is perfectly trained, we should get the values. Okay, see, we got here 1 and 5. Okay, let's check, give one another try. 208 and 87. 12 and 17. What we should have got is 6 and 9. Okay, again we have to 6 and 9, what we should have got. For a bit accuracy. Okay, let's change this data a bit because we are 208, 87. Okay, finally we got 6 and 9 values. Okay, let's test with another data 121.15 and 0. Close. Let's see. We should get 17 and 12 and 17, I guess. Yes. 12 and 17. Now let's take another data. 6 134.47. It's actually the more we use it, the more trained it gets. Somewhat the accuracy for this result is a bit low. 14 15. Okay, we got it. 6 and 134. Somewhat the accuracy is a bit low because number of data points we don't have enough. For large data points, the accuracy will be more. As we know, in case of neural network, it is always like that. The more data points we have, the more is its accuracy. 50.94, 50.98 should be 13 and 16, right? Okay, 13 and 16. As we can notice that we are getting it in fewer tries now. So slowly, once let's give another try to it. 227, 131. This is how actually machine learning algorithm works. The more we use it, the more it gets trained. String 11 and 18. Okay, let's change the value a bit. Okay, we got 10 and 19. So this is how it works. So okay, actually what we got here is initially we induced some type of error in each element, and then we noted its mode 1 and mode 2 period values, and we trained the algorithm with this. Now whenever we put any frequency data of any proper structure without knowing where its defect is in this algorithm, its mode 1 and mode 2 period values, as I showed the data analysis that I have done, or then on running this code, it will give us the element numbers where the possible defect might be. So as we saw here, okay, now let's go to this. So here Opensees is what I have used. Okay, now I want to say some of the scopes or future scopes that is involved in it. That is, if we see the final algorithm that was trained with our data is somewhat giving some ambiguous data, which accuracy can be increased on increasing the number of element numbers. Suppose, as we see here, here 2% damage induced in the area. I have taken that 1% and 2% values. 2%, 3% values are basically just into 3 and into 3 into 2 datas of the data that I got. That's why basically they are linear itself. So that won't create much of an difference in the accuracy. That will actually becomes ambiguous in the data, for which I have not taken the 2% and 3%. Suppose the data sets of 2%, 3% are far much different than being two, just the 2 times and 3 times, or else if I multiply 200 and 300 or 3000 to those data points, then there will be far enough, so that might increase some more accuracy in my value. So these are the final results that we got. This one is before being clustered, this is after being clustered. So, okay, some of the future scope it is that this can be extended to RCC structure, and I have taken just a 2D truss structure, but this can be also extended to 3D truss structure. Now, some of the possible sources of error in this is, first of all, the data Cypress editor data. There we have to be very careful that one by one each element we induce the error of area and then we store it. And another problem, it may be in this algorithm. So here the most optimal or free algorithm that is available in the internet, that is the k-means algorithm. K-means ANN cluster algorithm that I have from sklearn library that I have used here. So maybe the accuracy might be a little bit less only because of this algorithm. The accuracy can also be increased using any other algorithms which are paid algorithms or different type of algorithms that are available. And then we can get more reliable data in this. So this is what my final year project is. And I have done the AI application too. Okay, thank you. Thank you very much.